46 years ago, this mountain killed 57 people in the worst volcanic disaster in American history. Right now, it is shaking again, and the ground on top of it is doing something that should not be possible if a real eruption were building. Hundreds of tiny earthquakes have rattled beneath Mount St. Helens since early this year, and at the same time, instruments bolted to the mountain show the surface quietly sinking instead of swelling. Everybody's gut instinct says shaking plus a volcano equals magma rising toward the surface. What the data actually shows is the exact opposite of that instinct, and figuring out why is the only way to know whether this is routine or something that deserves serious attention. The USGS recorded 368 small earthquakes at Mount St. Helens between February 4th and June 21st of this year, most less than magnitude 1 and too small to be felt at the surface, occurring at a median depth of around 3, 5 miles below sea level. By early summer, the rate had climbed to roughly 38 located earthquakes per week. And crucially, as of the most recent USGS Cascades Volcano Observatory notice, all volcanoes in the Cascade range of Oregon and Washington, including Mount St. Helens, remain at normal background activity levels. No eruption warning, no elevated alert. The aviation color code stays green. But normal alert level does not mean nothing is happening. It means what is happening fits within a pattern this mountain has shown before, a pattern with a specific name that tells you more than any single earthquake count ever could. That name is recharge. Magma slowly rises through the lower crust and accumulates in a reservoir about 5 to 6 miles below sea level, the USGS explained. Recharge events can occur when magma enters this upper reservoir and increases stresses that lead to earthquakes. The scientist who spoke publicly about this activity put it in deliberately plain terms. We don't have an ability to actually go down into the earth and see what's happening. So what we're doing is really inferring, like, the earthquakes are the symptom. If you want to take this into the doctor's realm, earthquakes are the symptom and the diagnosis is, oh, this is consistent with a volcano that's recharging. That word, recharging, is doing enormous work in this story, and it is worth understanding precisely. A recharge swarm is not the sound of magma breaking free toward the surface. It is the sound of a reservoir slowly refilling miles underground, gently pressing against the rock that contains it. The earthquakes are a symptom of the mountain feeding itself, not a symptom of the mountain erupting. The USGS said this activity can continue for years without an eruption occurring, and that elevated rates of seismicity interpreted as recharge have been observed at Mount St. Helens in the past. It genuinely helps to understand just how small these earthquakes actually are. The magnitude scale does not behave like a simple ruler. It behaves more like a set of stairs where each full step down represents a massive drop in actual energy released. A magnitude 1 earthquake is not a slightly weaker version of something you would notice. It is thousands of times fainter. The kind of event that only exists as a small squiggle on an extremely sensitive instrument. You could stand directly above one of these earthquakes on the mountain and never feel a thing. That is the actual scale being discussed here. Dozens or hundreds of faint whispers rising from a reservoir far below. Not a single sharp crack near the surface. And that distinction matters more than the raw earthquake count ever could. Because 100 whispers from miles down means something entirely different from a single sharp crack a few hundred feet under the crater. That gap is the real dividing line between a routine week and an actual emergency. And it depends entirely on where these earthquakes are happening and what the ground directly above them is doing at the same time. Which brings us to the detail that tends to produce the most confusion, and the one most worth sitting with carefully. Mount St. Helens is not bulging. It is not swelling outward. Its surface, tracked continuously by extremely sensitive instruments, has been slowly settling downward. Earthquakes paired with a rising volcano would mean magma pushing up toward the surface. Earthquakes paired with a sinking surface is a different animal entirely, and understanding that difference is the core of everything that follows. The system underneath this mountain operates on 2 separate levels, and critically, they are not locked together. Far below, miles down, the reservoir can be actively repressurizing, taking on fresh magma and charging up like a battery. Scientists have documented exactly this at Mount St. Helens. After its last eruption ended in 2008, monitoring showed the underground magmatic system steadily reinflating even while the volcano itself sat completely silent at the surface. That is the charging half. Now consider the shallow half, closer to the top. The young lava dome the mountain built during its last eruption has been doing exactly what freshly formed volcanic rock naturally does. It cools, crystallizes, releases trapped gas, and slowly contracts under its own weight. These shallow processes pull the surface downward on their own, completely independent of what the deep reservoir is doing. Put the two halves together, and you get the strange but non-contradictory picture of a volcano quietly charging far below, while its shallow skin cools and sags above it. Surface sinking does not mean magma is leaving the system. It means the top layer is cooling while the bottom layer quietly fills. That is precisely why this mountain keeps catching people off guard. If this current activity feels unprecedented, it is worth knowing that Mount St. Helens did almost exactly this before. During a 3-month span, beginning in mid-July 2023, more than 400 earthquakes were recorded at Mount St. Helens, most less than magnitude 1 and too small to be felt at the surface. And while swarms of earthquakes also occurred in the late 1980s and early 1990s, none directly led to volcanic eruptions. The 2016 swarm was nearly identical to what is being recorded now, running for roughly 8 weeks, climbing to close to 40 located earthquakes per week, with the largest barely reaching magnitude. Though it's 1. 3. The USGS reviewed that swarm and stated flatly there were no signs of an imminent eruption. What they were watching was recharge, and the process continued for years without ever producing an eruption, because that is what recharge does. It is a process measured in years and decades, not days. It is also worth being honest about what happened when that particular recharge cycle finally did produce an eruption, because the outcome looks nothing like the picture the word eruption puts in most people's heads. When Mount St. Helens erupted between 2004 and 2008, it was not a repeat of the 1980 catastrophe. It was a slow, grinding extrusion of thick, pasty rock that piled up spine after spine into a growing dome over 4 years. Dangerous up close, but continuously monitored, and nothing like the sideways blast that defined the original disaster. The mountain had recharged quietly for roughly 17 straight years from 1987 to 2004 before that eruption finally arrived. 17 years. So whenever you hear this mountain is shaking again, the correct reference point is not a ticking countdown clock. It is a mountain doing the same slow, patient underground work it has repeated for decades. To understand exactly why any activity at this mountain carries the weight it does, it helps to go back and look at 1980 directly. Not to frighten anyone, but to show precisely what a genuine countdown looks like, so you can measure this current activity against it fairly. Because 1980 was loud, visible, and constantly accelerating in every possible way. The opposite of how quiet this current swarm has been. That reawakening began in March of 1980, after 123 years of dormancy, with earthquakes and sudden bursts of steam. Then came something with no real equal in the modern geological record. The entire north flank began physically deforming outward, not settling, not sinking, bulging as magma forced its way sideways into the flank at a rate of roughly 5 feet a day. Over that spring, the bulge pushed outward by something close to 450 feet. That is visible, accelerating, shallow deformation. Exactly the textbook warning sign that today's mountain is pointedly not displaying. The USGS notes that Mount St. Helens has a high probability of renewed eruptive activity, but also that neither a large debris avalanche nor a major lateral blast like that of May 18, 1980, is likely now that a deep crater has formed. What made 1980 a genuine countdown was never one dramatic number. It was the relentless acceleration. Over roughly 2 months, every signal stacked and intensified. The earthquakes climbed steadily upward toward the surface. Steam explosions grew more frequent. The bulge swelled visibly day after day. Then, at 32 minutes, past 8 on the morning of May 18th, a magnitude 5. One earthquake shook that overloaded bulge loose. The entire north flank collapsed at once, producing the largest landslide ever recorded on Earth. With a huge section of the mountain suddenly gone, the pressurized system trapped inside was instantly uncorked. It blasted sideways, flattening forest across roughly 230 square miles, stripping away the upper 1,300 feet of the mountain and dropping its summit by more than 1,300 feet. Ash reached Idaho by noon. The eruption killed 57 people. Set the two pictures side by side, because this comparison is the whole argument in one place. In 1980, the surface was bulging outward at roughly 5 feet a day. Today, it is quietly sinking. In 1980, earthquakes were climbing steadily toward the surface as magma physically forced its way upward. Today, tiny earthquakes sit miles down, exactly where a reservoir is calmly refilling. In 1980, 3 separate signals were all screaming in the same upward direction at once, accelerating, shallowing, inflating. Today's activity is faint, deep, and admittedly unsettling to look at on paper, but fundamentally different in every measurable way. The USGS is clear that Mount St. Helens is the volcano in the Cascades most likely to erupt again in our lifetimes, and that the types, frequencies, and magnitudes of past activity will likely be repeated in the future. That is not a reason for panic. It is a reason for ongoing attention. There is a meaningful difference between those two things, and understanding where the current activity sits along that spectrum is exactly what stops false alarms from eroding public trust in the warning systems that actually matter. Scientists are not guessing about what a real reawakening would look like. They already know the specific tells, because this exact mountain has shown them before. A genuine countdown would announce itself through a specific cluster of changes. The first would be a clear migration, earthquakes gradually shifting from deep down where recharge lives upward toward the surface, tracing the physical path of magma on the move. The second would be a distinct change in the character of the shaking itself, the emergence of harmonic or volcanic tremor, a continuous vibration signaling fluid and gas actively moving through the plumbing rather than simple rock cracking. The third, and perhaps the clearest reversal of this current situation, would be the surface flipping from sinking to rising, with measurable inflation replacing the ongoing deflation as pressure reaches the shallow system below the crater. The fourth would be a noticeable rise in volcanic gas, particularly carbon dioxide and sulfur dioxide climbing, as magma approaches the surface. The fifth would be actual steam explosions, the mountain clearing its throat with bursts of superheated water, exactly as it did repeatedly in the weeks before 1980. Not one single item on that list is currently happening at Mount St. Helens. What is happening instead is a faint, patient swarm sitting far below a surface that continues to settle, the clear signature of a volcano refilling on a schedule measured in decades rather than days. And this happens to be one of the most heavily instrumented volcanoes on the entire planet, wired with seismometers, satellite radar capable of measuring ground movement down to the millimeter, dedicated gas sensors, and precision geodetic receivers, all feeding directly into the Cascades Volcano Observatory built specifically because of what happened here in 1980. The USGS stated clearly that the current level of seismicity does not suggest an imminent eruption, while noting it is still considered within the background range. That density of monitoring genuinely matters, because it means any shift from quiet recharge toward a real reawakening would not slip past unnoticed. The warning signals would show up one after another in instruments purpose-built to catch exactly them. The reason today reads as routine is not because anyone is looking the other way. It is because the people watching hardest, using the best monitoring tools ever pointed at this specific mountain, currently see a volcano refilling, not a volcano actively rising toward eruption. There are concrete things worth tracking in the coming weeks, the same things the observatory itself is watching closely. First is the swarm's rate, whether it keeps climbing, holds steady, or fades. Second is the ground itself, whether the ongoing deflation continues as expected, flattens out entirely, or reverses into measurable inflation, which would be the one shift that would genuinely change this entire story. Third is simply whether the Cascades Volcano Observatory issues any new statements about this activity, and whether the word recharge appears in them, which would confirm the pattern scientists already suspect is underway. Until one of those specific signals actually changes, the honest takeaway stays steady. A volcano can shake without swelling, refill without erupting, and sit calmly at normal alert status while its deep plumbing quietly fills far beneath the surface. The USGS has said this elevated seismicity has been interpreted as recharge, and that this activity can continue for years without an eruption occurring. That is not the beginning of the end. That is simply the sound of a living mountain resting between chapters of its own long story. When the real countdown eventually starts, it will not look like this quiet swarm. It will look like 1980, loud, shallow, and rising fast. And understanding that difference now, while everything stays quiet, is exactly what will keep you from mistaking the next false alarm for the real thing when that day eventually comes.